Hi, and welcome to Geeks for Geeks. Today, we would be discussing the post contest analysis of GFG Coding Contest 85. So, can I have a quick one in the chat if I'm visible as well as equally audible? Just give me a quick one. Hi, Rishit, how are you? Okay, so let me just check my internet speed. It should be good enough. Okay, it's good. Yeah, okay. Hi, Zayad, how are you? Okay, so we see similar faces today. Okay, tech code. Thanks a lot. Let me just see for myself if I'm visible. Mhm. Okay, fair enough. Let me know if you face any lagging or something. Okay, so we would start off with the very first question, but let me first give you the feedback of this. Today's contest was on a voice is lagging. Let me just see. Mm-mm-mm. Okay, now it's fine. But yeah. Mm, mm. Okay. No, voice is fine. Just video quality is a bit bad. Don't know. It might be a scenario that I'm using artificial lights. Okay. Now also that is solved. Okay. So video post. Okay. Actually, I was switching the network itself. Okay. Fair enough. So let me first give you the feedback from my side. The first problem was a little bit easy problem, but on the scale of easy, it was towards the hard easy. Okay. The next problem, trees and arrays, it was a hard level problem. And the third problem, whose intuition is a little bit tough, but if you just observe and draw it down in a pen and paper, then that problem is a medium level problem. Okay, so I think we can move forward. So how many problems were you able to solve? Can I have a quick feedback? Till then, just quickly recapitulate in your mind that this is the problem itself. Yes. Okay. So just tell me, yes. So just tell me if the reading of this problem is done or not. Okay. So now it is now never really asked for any help towards this, but from the last contest, the problems like this contest usually have hard solutions. So a lot of negative feedbacks are there, not a lot, a few of them, but I seriously require to combat them, but I can't do it myself. So if you are able to understand the solution and you are able to get something out of this video tutorial, this time make sure that you give a positive feedback. If I contribute, and if I don't contribute, you can give a negative feedback, but I really want to see how many of you are getting benefited, how many of you are not getting benefited. Okay, fair enough. So let's move forward. And mm, 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 entire screen and low video quality. Yeah, now it should be there. Okay, so prefix subsequence, this problem seems to be a little bit tough. Okay, but let me tell you one small thing about it. Okay, and this problem would seem easy. So basically in this problem you are given a string s1 and a string s2. Basically here the names are different, s and t, but let's take s and t itself. Okay, so you are given two strings s and t. What you need to do is you need to return the length of the longest prefix that is not present as a subsequence in T. So what you need to do is length of the longest prefix that is not a subsequence, that is not a subsequence of T. This is the problem statement. Okay, summary of the problem statement in one line. So if you just observe and break down this problem statement, you would see a different thing. So instead of length of the longest prefix that is not a subsequence of T, you can see that length of the longest prefix, okay, that is a subsequence of T, and we just add 1 to it. We just add 1 to it. So we can say that, suppose, let us take the example that suppose length or the budget which I can't spend. Budget I can't spend. Let's suppose I have a budget of 10 and I need to report that the maximum budget I can't spend. So it would be just the maximum budget I can spend plus 1. This would be the scenario. So in the same manner, I can say that if someone is asking me for the longest prefix that is not there as a subsequence of T, then I can just say the longest subsequence that is available plus 1 would be the length that is not there. Am I clear with this intuition or not? This intuition is absolutely the most important part of the solution. Just give me a quick one if this intuition is clear. Next, we would discuss how to solve this problem. But this is the intuition that would take us towards the solution. Just tell me quickly if this intuition is clear or not. This one is quite, just give me a quick one if this intuition is clear. Can you repeat the intuition once again? The intuition is, suppose I have a budget of 100 and I am asked the maximum budget I can't spend. So it would be just that. My maximum capacity plus 1 would be the capacity I don't have. So in the same manner, if the question is asking us the maximum length which is not a subsequence, then I can simply say maximum length that is a subsequence plus 1. That would be our answer. Rishit, can you quickly tell me if this thing is clear or not? Like suppose smallest nth largest, yeah. Okay, so now I'm waiting for Rishit. Clear. You are telling maximum instead of minimum, same ways. Okay, so length of the longest prefix, that is also, so I can say. So now in this question, what I need to do is I need to find the length of the longest prefix which is also available as a subsequence, and the answer would be just plus 1 to that. Okay, so now see, if A B A D, so if this prefix is present, then this prefix should also be present, this prefix should also be present, this prefix should also be present, and this prefix should also be present. It is just like that. If it is asking for the longest prefix, then it would start from the front. So if till A to AABAD is present in as a subsequence, then AABA is should also be present. Then AAB should also be present. Okay. Then simply AA should also be present. Then simply should A simpler should also be present. So what you can do is you can start from A, search it if it is present as a subsequence or not. Then again AA, search if it is present as a subsequence or not. Then AAB, search if it is present as a subsequence or not. Then AAD, we keep doing that until we reach a point where that is not present as a subsequence. Simple enough. At any point, if we break, we can say, yes, this is the breaking condition. Okay. So now the solution is very clear. So what we would do is we would just take the screenshot of the sample test cases, and then it would make more sense. So see, what we would do is see, we would take 2 pointers. Okay. one pointer is this and one pointer is this. So basically both A and A are same. So this A would move forward to B and F. Okay. These two are not equal. Okay. But we need to satisfy this B. So we would remove this and we would move forward. Now this B satisfies that B. So now both would move forward. So now I can say that this would work here and this would work here. Now this B and E are different. So now we would again move forward to this. Okay. Now again B and F, it is not equal. So now this would move forward to index out of bound. So the maximum length I have encountered, okay, the maximum length I have been able to satisfy is 2. So the answer is 2 plus 1, that is 3. Okay, let's take one more example so that becomes crystal clear. Okay, okay, yes. So now see, I stand here and I stand here. So these two are satisfied. So in the next iteration, both would move forward. Okay. So now in this part, we can see that we are able to satisfy a length 1. Okay. Now in this scenario, satisfaction plus 1 is equal to 2. But 2 is not the length of the given value. Okay, we don't have 2 length to satisfy this condition. So we can write a if statement that if the answer we are computing, that is the answer plus 1, is greater than the length of the string, then the answer would be minus 1. Can I move forward to the implementation? I would just take 2 pointers. If these two are equal, both would move forward. If these two are not equal, then just would move forward. Why? Because we need to satisfy all of this. Not equal, only this would move. Both equal, both would move. Am I clear? Just give me a quick one and we would move forward to the implementation. Just give me a quick one. Binary search is the best option to solve. Yes, absolutely. But instead of that, we can just take 2 pointers and we can just move forward. Anyone who is not able to understand, give me a 0 in the chat. Chrome tab, prefix, subsequence. How to use binary search in this? Basically you can use binary search on an answer. Like you can consider that length 1 is preferred. So if length 1 is true, then we would move to length 2. So this is a monotonic sequence, that if length 5, so just it's just like that. If length 5 is satisfied, then length 4 is also satisfied, 3 is also satisfied, 1 is also satisfied. So this is a kind of monotonic function. Yes, 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 no, 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 no. It's not that yes, no, yes, no. If something is like this, that yes, 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 no, 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 or no, 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 yes, yes, if these two conditions are satisfied, then it is a monotonic function. If it is a monotonic function, we can use advanced binary search. But being tagged as an easy problem using monotonic function is not that we expect from here. Okay, fair enough. But it's saying 2. Can you please tell me in which company do you have a full-time offer? I'm still in my 4th year, so I still can't join any full-time role. I did using binary search, but advanced binary search is a overkill to this problem. Okay, it's just like that. Suppose the prefix, suppose the prefix, like suppose prefix of size 5 is searchable. Suppose AABA is present. So A would also be present, AA would also be present, AAB would also be present, and then AABA is also present. So for all this, the answer is yes, and more than this, the answer is no. So this is a monotonic function. If this is a monotonic function, you can directly do a binary search on the length, and this would be solved. So now we would take a pointer for S. So I would name it as Si, and pointer for T, I would name it as Ti, and both would start from the very beginning. So now we would take care of index out of bound of both of them. Either of them index out of bound is there, we would stop the iteration. Okay, so we would say if Si is less than n, either of them means and condition should be there. Okay, and Ti is less than m itself. Okay, so now we would say if S of Si is equal to T of Ti. If both are true, then what we would do is Si plus plus and Ti plus plus. Both would move forward. If it is not true, then only Ti would move forward. That is, we would move like this. Okay. Then we go down and we would say that if we are standing at index out of bound of the given S, then that means the whole string is present. If the whole string is present, then we don't have any prefix which is not present. So answer is -1. So we would say if S of I is equal to n, then return -1. If that is not the scenario, we would return as index is 0 indexed but length is 1 indexed. So we would just say return Si plus 1. Now we would just compile and run. Done for this. Okay, fair enough. Tell me the line number at which you are not able to understand. I hope this is clear. Till then, just take 30 seconds. Two pointer is the optimal solution. No, two pointer is not the yes, two pointer for this question. Two pointer is the optimal solution. Binary search would also work, but binary search is a kind of overkill and it has a time complexity greater than this. Okay, for anyone for whom this is not clear, Mayank Vijay, can you tell me the point? Question not understood. Then you need to just understand the question in Hindi. Yeah, let's take the statement. Okay, translate it to your mother tongue, and then you would understand better. -1 condition. So see, so index is 0. Index is 0 indexed. Okay, index is 0 indexed. So if index is at the nth position, then that means length is equals to n plus 1. But n plus 1 can't be an answer because we don't have, if the length is only n, then n plus 1 length is not possible. So we simply return -1 in this. Can you do in Hindi? No, many people in this stream are from different parts of the country, so I need to take consideration of them too. That is why. So how many of you are not comfortable with Hindi? Give me a quick two in the chat. Okay, so I would move forward to the next question. Stop sharing and then English only. Okay. So share the screen, and this would be the Chrome tab, and this would be the next question, that is trees and arrays. Okay, this question you need to understand a little bit, to be honest. But this solution is more intuitive. Yes, absolutely. This solution is more simpler, more intuitive. So this problem has the least solve count. Okay, this question has the least solve count. Now let us see how many of you are able to solve this. Give me a quick one after you're done. Okay. Yes, many people are not able to solve this. Okay. Let's move forward. So now this problem is very interesting, to be honest. Let me just tell you how. Okay. So see. So let me just. Mhm, mhm. Share screens, window, open board, and it's done. Okay. So now let us see this. See this problem. Okay. So now in this problem, you are given a tree structure. Please understand this very carefully. And it is not promised that this would be a full binary tree. It is not promised, but I'm just drawing it for convenience. Next, it is also indexed. Root is 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12, then 13, then 14, and then 15 itself. Okay. So now in this, a tree is given. Suppose you have the tree. Next, you are given a positive array and a negative array of size n. What is n? N is the number of nodes. Okay. So now you can assign values in this node either from the positive or from the negative. Okay. And you need to return the maximum sum path from root to any node. Okay, maximum sum path, anything that is mentioned, just let me see. uh, Find the maximum root to leaf. Yeah, root to leaf. Yes, absolutely. Root to leaf. Root to either of the leaves. Like suppose let us take root to this leaf. Okay, or root to this leaf, or either root to this leaf, or either root to this. So now you would say that I would have the maximum positive numbers. I would sort them and I would assign them. Okay. And then I would just take into consideration which has the maximum values. I won't ever see the negative values. Very common intuition. But the problem is that you can use at most k continuous values. K contiguous values. It just means that you can at most take k continuously and then you need to switch. Okay. So either from the arrays, you can take k continuous and then you need to take from the different array. Again k continuous at most, and then again from the different array. At most means what? 1 also, 2 also, 3 also, till the value of k. So if you have reached k, then you need to switch the array. Okay. Like k, translating the same in Hindi would be that k बार एट मोस्ट k बार हम लोग ले सकते हैं. k बार के बाद अगर हम लोग पॉजिटिव ले रहे हैं तो एक नेगेटिव से लेना होगा, और दो नेगेटिव लेना होगा, और तीन नेगेटिव लेना होगा, आपकी इच्छा है. बट k एटमोस्ट एक array से कंटिन्यूअस ले सकते हैं, चाहे वो नेगेटिव से लो या पॉजिटिव से लो. ओके. k कंटिन्यूअस लेने के बाद यू नीड टू स्विच द array. Okay. So now let us take and understand the example that is given. Okay. So we go back, we do this, and then we see how we are building up the solution. Now let us see this. See how we are building this solution. This problem is a little, as I said, this seems a little bit hard to understand. Okay. Yes, absolutely. I would repeat the test cases. Don't worry about that. Mhm. Chalo. So now see, it is told that 1 is the root, so it won't have any parent. So 1 here is the root. Okay, 2's parent is 1. So 2's parent is 1 itself. 3's parent is 2. 3's parent is 2. 4's parent is 3. Okay, so this is 1, 2, 3, 4. Okay, 4's parent is 3. This is just the parent array. So see, 4's parent is 3, 4's parent is 3, 3's parent is 2, 3's parent is 2. Okay, so now this is the given tree. Basically, this is a skewed tree. The name of this tree is a skewed tree. Okay, so now I need to assign values. To assign values, I would just make this a little bit big. Okay, so now see this. So this is index 0, 1, 2, 3. Okay, so index 0, I can assign 16 value to it. I can go to index 1 and I can assign 7 to it. But if I assign two values, then I would miss out 13, which is a greater value. Okay, so if I assign 7 also, then I might miss 13, but I want to focus on large values. Okay, so okay, this won't be 0, 1 and 2. This would be 1, 2, 3, 4, because nodes are one indexed. So I would go to same ways. I would go to 1 and I would assign 16. Then 2's 7. No, I won't assign that. Okay, so I would take one negative value, because if I assign 7, then I would exhaust two values continuous. Then I would need to leave 3, because see, if I take 16 and 7, then I have already taken two consecutive values. Now I need to switch array. So I miss 13 and I now need to take minus 8. So if I don't take minus 8, if I take 16 and 13, then I need to bear a loss of minus 3, which is much better. I'm getting a bigger positive value as well as a less negative value. So this is much better. So I would take 16 for 1, 2, I would take minus 3. For 13, 3, then it is 13. And then 4, we can just take continuous k values. So I can just take 10 itself. Okay, so you can see that I have taken not more than k continuous. That what is the value of k? K is 2. I have not taken more than two continuous values from a single array, either from A, either from B. So now the sum of this is nothing but 16 minus 3, which is equals to 13. 13 plus 3 is equals to 26. 26 plus 10 is equals to 36. That is how the value is 36 here. Am I clear? Just give me a quick one and I would tell you the second sample test case. Just give me a quick one to this. I would take one more example, because this seems a little bit hard to understand. So see, in this, we have a single node that is 1. So the most basic approach would be that we would just take the positive value and we would assign it, because positive value is much better than 12. So I would just take a positive value and this would be our answer. But basically, this tells us a way to solve this problem. Am I clear with the sample test cases or not? Give me a quick one. Anyone who is not clear with the sample test cases, tell me now itself. Tell me now if you are not clear with the sample test case. Tushar Batra, tell me the point at which you are not able to understand. Please don't spam. Tell me the point. Tell me at what point you are not able to understand. What if there are multiple route to leaf paths to consider? Yes, absolutely. So basically it might be a scenario that here also route is there, here also route is there, here also route is there, here also route is there. So you need to consider everyone and you need to return the maximum out of that. Like the tree is not skewed. So if the tree is not skewed, so let's take an example of this also. Like let's say the tree is not skewed. and the sum of this is 100, the sum till this point, root till this point is 80, this is 30, this is 10, this is 12. So then you need to take consideration of all of that and you need to return the highest of that. Simple enough. That is why I have brought a full binary tree, because in the sample test case we are only given a skew tree, so you need to return the maximum one. If one parent has multiple child, what if me one parent? If one parent has multiple child, then you need to return the maximum out of that. It is already mentioned in the question in the last statement. Find a maximum path sum from root to leaf in such arrangement. Root to leaf, so it can be any leaf in such arrangement. Clear, thanks. Tushar, am I clear? Just give me a quick one if this thing is clear to you, Tushar. Most good. Good evening, Ma. Okay, just give me a quick one if this is clear, Tushar Batra. Okay, this is clear. Fair enough. So now we would move forward. So now if you observe in this problem test case, if you observe in this test case, we saw that taking into consideration all the positive values won't help us. Okay, so see, we can't take continuous k values. Okay, the first idea was, see, the first idea was a greedy approach. Let's take a greedy approach. So greedy approach would be that we can focus on max values. So to focus on max values, we need to sort it. But if we sort it, then we can't really know that how many continuous elements we have taken. So we need to preserve the ordering. So in this question, we need to preserve the ordering because we can't take continuous k elements. Okay. So if we need to preserve the ordering in this question, then we can't do sorting. If we can't sort it, then greedy would definitely fail. Okay. So now we need to think of something else. Like let's try to think of other greedy ways to solve this. Now we can't really decide that whether to take this 7 or not. Okay. Whether to take this 7 or not, or 13 or not, or 10 or not. It might be a case that at this point 100 seems very tasty, but towards the after 100 there is 1000 or something. So if we take this at this point, if k is exhausted, then we need to leave this one. So we can't really decide that what values are there in future, because the future values affects our solution very much. Okay, we can't really decide, because it might be a scenario that up till now 100 is the maximum, so we saw okay 100 is a very big value, we would take it, and at this point k gets exhausted. So at this end, suppose we have this much big number which would have benefited us a lot. Okay, but now as a k is exhausted at this point, we can't take this, so we can't really decide on the future values. So if the greedy fails in either of the ways, what comes into picture? So if greedy fails, then the only thing that comes into picture is the dynamic programming begins. Okay, so greedy fails, greedy is failing, so it's a clear indication that this problem is a dynamic programming problem. Am I clear with the intuition? Give me a quick one. Give me a quick one. Greedy is failing either of the ways, because we can't really decide that in the future values what values we need to consider. Okay, so if greedy is failing at this point, then this problem is a dynamic programming. So we say na, when what is the indication that this is a greedy diffy problem? Greedy is failing at either cost, so we need to take in consideration of the dynamic programming thing. Okay, everyone clear with this intuition? So if you are clear with this intuition, then the problem is just about dynamic programming and a little bit of understanding is left. Okay, so now we need to really decide the states and all. We really need to talk in terms of dynamic programming. So now this would get heated up a little bit. Why? Because we are using dynamic programming on trees, which is an advanced topic. Okay, so now this discussion would get heated up a bit. So be ready. Okay. So now, if we saw this last test case, so whenever we think of dynamic programming, so we first think of the smallest test case that we can solve it by ourselves. So basically the base condition. So the base condition can be like this, that for the root value, there are only two considerations, for the positive value or the negative value. For the root, we don't have any other choice. We have both the choices. Either we can consider negative or we can consider positive. We have this consideration. Okay, by this test case, we know this. This test case is giving us this indication. So this test case would act as a base condition. I would say that if the number of node is just one or it is the root, then I can take into consideration two ways. So it is just like this. Okay, I would just say you this. So this is 0 1 knapsack problem variation. For every index, for every index, for every index, we would decide to either take it or leave it. Okay, take or leave, 0 1 0 1 0 1. Only modification in this is that we can't take more than k. More than k is not allowed here. Other than this, we can leave as much as we want. We can take as much as we want. Now in take, we can either take from A or either take from B. Take from A, take from B. Okay, we can just do this, do this, do this. Okay, so am I clear with this thing or not? Then I would move forward to the implementation. Now this problem is just of implementation, and the implementation would be on a different level. And I would show you that also. So basically, there would be two steps. Like first one would be for if I consider from A, if I consider from B. Okay, there are only two conditions. This is first take. This is one variable, like one dimension. Then the next dimension would be for k. Okay, like if k is equals to 1, then I would take that consideration. K is equals to 2, I would take that consideration. Now k's maximum value is less than equal to 10. So this means k can also work. Now the next thing that we have left is the index itself. So index a comma b and k, we have these three. Okay. So we have index to consider. We have A or B. So we would just say that if we consider A, what would be the solution? If we consider B, what would be the solution? And then K would be a variable thing that would be going on at the other half. Am I clear till this point? Then I would move forward. So for that case, it's both root and leaf because only one node. So base cases will be a leaf node. Am I correct? Yes, absolutely, you are correct. Base case would be for a single node. Am I clear? Can I move forward to the implementation now? I don't have much to talk about. The next thing I can do is explain the implementation. Give me a quick one so that I can move forward to the implementation. So it's just that I would either take element from A. So if I'm taking element from A, then I would do k minus 1. If I'm taking element from B, I would do k minus 1. Okay, so if k is equals to 0, then I need to interchange the values that I'm checking. What is A and B again? A and B again is nothing but if we are considering elements from A, we would keep it in 0. If we are considering elements from B, we are keeping it in 1. 0 में A के वैल्यू सेव करेंगे, अगर हम लोग A लेंगे तब क्या होगा? 1 में B के वैल्यू स्टोर करेंगे, अगर हम B लेंगे तब क्या होगा? Because we don't really have A and B as index, so we would just use 0 and 1 as index. 0 means A, B means 0 means A, 1 means B. Simple thing. Index is 0 to n minus 1. What is the logic but? So basically the logic is that we would consider each one. Okay, like whatever we do in knapsack problem. So see, it is just like this problem. See, okay, suppose there are 1 2 3 4. Okay, so if I take 1 in consideration, then I would have a sum of 1. If I don't take 1 in consideration, I would have a sum of 0. Now let's take a decision for the second element. If I take into consideration 2, then the sum would be 1 plus 2, that is 3. If I don't consider the index 2, then the sum would remain as 1. If I consider the index at 2, this would be 0 plus 2, that is 2. If I don't consider it, then sum would remain the same. Now let's take a decision for the third element. Okay, so if we take a decision for the third element, if we include it, the sum would be 3 plus 3, that is 6. If we don't include it, sum would remain the same. If we include 3 to 1, then 1 plus 3 is equals to 4. If we don't include it, the sum would remain the same, that is 1. Now 2 plus 3, if we consider 3, this would become 5. If we don't consider it, it would remain as 2. If we consider 3, then this would be 0 plus 3, that is 3. If we don't consider it, it would remain the same. Now let's take a decision for the last element. If we consider the last element, this would be 6 plus 4, that is 10. If we don't consider the last element, this would be 6 plus 0, that same would remain. Don't consider means what? We won't take it. So if we consider the last element, 3 plus 4 is equals to 7. If we don't consider it, the sum would remain the same. If we consider last element, 4 plus 4 would be equal to 8. If we don't consider it, the sum would remain the same. And this would go on. And this is the logic. So basically, we would just do a consideration that for once, we would consider from A. In the next one, we would consider from B. From once, we would consider from A. And the next one, we would consider from B. We would take the maximum out of them because we want the maximum value. Now am I clear? So basically we would build a graph and we would do a DFS and we would move in either of the ways and we would say max of both the ways. Am I clear? Why are we not sorting? Why are we preserving the index? So if we are sorting the values, so see, if we are sorting the values, let's talk about that also. Let's suppose we have 10, we have 9 here, we have 8 here, and then we have 1, 2, 3. So if we sort the values, we would have 10, 9, 8, 1, 2, 3. So now if we start taking the values, we can't really decide that we are taking contiguous k element or not contiguous k element, because we can't really say that we are taking contiguous element or we are not taking contiguous element. Okay, so sorting would disrupt the ordering and we can't say that continuous ho raha hai ki nahi. We can't really say. That is why sorting won't work. Am I clear, Aman Singh? Since we need to take either A and B, so ordering would disrupt. Yes, absolutely. So now tell me, Aman Singh, am I clear? Ivan Gupta, am I clear with the logic that I drawed last time? This is the logic. We would, same thing. At this point, we are considering consider or not consider. In the same manner, we would do consider from A or consider from B. Nothing else. Am I clear with the logic? Chalo. Anyone else who is not clear what we are going to do, give me a 0 in the chat. If you want me to move forward with the implementation, which is a bit on the heavier side, give me a 1 in the chat and then I would move forward. What is the DP solution structure and the recurrence relation? That I would directly show you in the implementation. Okay. Chrome tab, tree formation, trees, and the arrays itself. So now the implementation would be a little bit. Okay, so we are using long again and again. So I would be saying that using LL is equals to long. Okay. Now we would globally define the graph that we are making. Okay. Basically, we have a parent array, so we need to build up a graph out of that. So we can do it locally also, but I'm doing it globally because we are using it again and again in different functions. So I'm doing it globally so that we don't need to pass it again and again. So I would say vector of int of c of 1e5 plus 1, 10 to the power 5. So I would just say 1e5 plus 1. So I would just say 1, 0, 0, 0, 0, and then 1. Okay. Fair enough? Yes. 10 to the power 5 plus 1. 10 to the power 5 is given, we would just add 1 to it. Okay. Now we would have long DP. The first one would be the number of nodes, that is 10e5 plus 1. Index can be what? 0 till 10 to the power 5. So I would just take one more, 1 0 0 0, okay, and then 1. Then we have A or B. So here we don't have something like A or B. So A is for 0, B is for 1. So we require an array of size 2. Array of size 2. Then K's value is still 10 to the 10. So we would just take a value of 20. Simple enough. And then we would initialize. We need the maximum value. So to get the maximum value in an array, we initialize that variable with a very minimum value. As this is a long, so int min won't work, might not work. So we would initialize a const of long, and we would name it as inf, and we would just say 1e17. Okay. Self long, well, int max. Int max is for integer, and we have defined it for long. Okay. Then we would globally declare an answer, and initially it would be, if we declare anything in global space, it would be initialized with 0. Okay. Then we would decide the void function itself. Okay. So now we would design the DFS. So DFS won't return any value. So we have the DFS. We would initialize it with the index. Then we would initialize it with the value of k. Okay. And then we would have all the vector of int and a, pass by reference a, and pass by reference b and b. By the way, my solution is a bit lengthy than the solution that is already given in the editorial, but for me this is more intuitive. Okay, so now I would visit the neighbors of that particular node. Okay, so see this. So suppose I have from 1 to 3, then 3 to 4, then 5. So from this node, I would visit all the neighbors, and then I would start assigning it, because from one index we can't really go to the next index. Okay, so we would visit the neighbors, as this is a graph or a tree. Okay, so we would say for int y is equal, for int y neighbor of c of the value x. So for the current root, for the current node, we are visiting all its neighbors. Now see the intuition. Now we would move forward with, for int I is equals to 0, I is less than k minus 1, and then I plus plus. Now we need to decide for two scenarios. What is the scenario? We need to decide the scenario for dp of the neighbor. Y is the neighbor? Neighbor of 0 of I plus 1, because nodes are one indexed. Okay, and the next one would be same, dp of y of 0 of y plus 1, but this time this would be 1. So this just means that here we would consider the values taken from a, here we would consider the values taken from b. Am I clear till this point? Just give me a quick one. Yk is 20. Wouldn't 11 be enough? Yes, absolutely, 11 should have been enough, but I don't know why. That's giving a segmentation fault, so 20. Okay. Just give me a quick one if till this point it is clear. This is for A. Okay, basically this is take from A, and this is take from B. That is why A means 0 and B means 1. Clear? Chalo, we can move forward. Okay, now we would come to this point. Okay, now I would say maximum of whatever was already stored, whatever we already have. Okay, dp of y of 0 comma I plus 1, and then we would say a of y. Okay, we would take values from a, and then we would say dp of, okay, I need to rub this, dp of x 0 and then I itself. Okay, so this would also solve the same purpose. Okay, max of the value which we already have. Okay, the value which we already have, and the new value, that is we are taking, this time we are taking from by, and this one would be dp of x, and then 1 and I. Okay, simple enough. Okay, first we are taking from a, then we are taking from b. A is for 0, b is for 1. Okay, we can do this. Next we come down. Okay, now this for loop for all this is done itself. For int I is equals to 0, I is less than b, and then this is done. So now the last condition. So if the neighbors of cx is equal to empty, like suppose we can say that if the particular node has no neighbors, if the particular node has no neighbors, okay, if the particular node has no neighbors, then the answer would be like this: for int I is equals to 0, I is less than 2, and I plus plus. Okay, then for int j is equals to 0, j is less than k, and j plus plus. Here we would just say that is equals to answer is equals to max of whatever is already stored and dp of x comma I comma j. Simply, here we won't make a decision whether to take a and b. We would just take the maximum out of that. Okay, maximum of all the values that is already there, 0 and 1. Okay, that is why we are doing it. Then we move forward. Okay, then we do a call for all the neighbors of it. Okay, first we are doing it for the root, now we need to solve for the root. So now what we would do is for int y, okay, c of x. Okay, for int y c of x. Basically we are just doing for all the neighbors also. Okay, for root it is done, then for the neighbors we need to do. Okay, so we would say dfs of y, k would remain the same, and a and b would also remain the same. Here just because of this x, instead of x we are passing the neighbors of x, because in recursion or in dynamic programming what we do, we solve it for the lower values also. So we are first solving for x and then we are solving for the lower values also. Okay, we are done up till this point. Okay, now this is done for k minus 1. Okay, yep, this is done. Now what we would do is for int I is equals to 0. चलो जाओ आप लोग चले जाओ, मैं थोड़ा लेट होगा. Okay, so for int I is equals to 0, I is less than k, and then I plus plus. Okay, so basically we would do one more consideration for I plus 1. So again we would copy all these conditions, but this time we would change a little bit. Okay, for less than k, dp of y of 0 comma 0. Okay, dp of I of 1 comma 0. Okay, the bottom one. So this one would be dp of y comma 0 comma 0. So we would just paste this. So I just want to show you the difference out of it. That is why I'm just copy pasting the things. Okay. Okay, this is done. And then we do a of y plus dp of x of 1 comma I. Okay, and next dp of 0 comma I. Okay. b of y plus dp of 0 comma y. Basically this is it. Now tell me, now just we need to build up the graph and call for the function. Tell me if this thing is clear or not. Give me a quick reply. Can you explain can you explain the line number 17 loop? Line number 17 loop. So basically we are looping for all the values of k. Okay, so if k is equals to 0, if k is equals to 0, then we can just take one value either from a or b. Then for 2, We are just seeing the previous two values, taking the maximum of it, and then considering again. Then for k is equals to 3, we are taking the previous two values and then we are considering. Can we iterate over cx vector cx? If c is a vector int, right? No, c is a vector of array. C is a vector of array. This is not a, this is a square bracket. Okay. Can I, am I clear? Give me a quick one. Give me a quick one if this thing is clear. The next problem is much easier in terms of implementation. Only the idea is a bit different. This problem is easier in terms of intuition, but in terms of implementation, this is a hard level problem. Just tell me quickly if the thing's clear or not. Okay. Anyone else? It's done. I'm still waiting for the last time. It might be a scenario that for you this is hard. Can you explain how are you picking up K? So see, it's just that suppose I am picking up A. This time I am allowed to pick up A. So see, suppose this is K minus 1. So if I'm picking, so 0 is assigned for A. So I would just write here also. 0 is for A and 1 is for B. So if this is the part where K is entitled, so if we are entitled for A now, then we are just taking the values of 0 as well as 1. Okay, this is for index 0 only. For 1, we are taking the consideration of 1 as well as 0. But for this time, A is only compared with A and B is only compared with B. Just see it. Here also dp of 0 is only compared with A of y. Here also dp is only considered with B of y. But here 0 means ay, but it is compared with B of this. Okay, first it is AA, then AB. This is AA, then it is AB. Okay, this is BB, and then it is BA. See, this is B, this is A. So basically we are just doing, see there, this is AB, this is AB. So see, if we have A, A, then B, B. So the combinations we can have are AA, AB, and then we can have BA, then again BB. We can have these four combination. That is why we have this. See this. Aman Singh, are you able to understand now why we are taking for consideration, how we are selecting the value of K? Sir, class कितने बजे चालू होती है? It starts from 8:30 p.m. IST. Okay, understood. We would move forward. To be honest, I am also afraid that this I'm implementing it live. So in this big code, I might make syntactical errors. I'm very afraid, to be honest. Okay, so what we would do is, as we have a globally declared thing. So first we would clear the globally declared thing. So for int I is equals to 0, I is less than n, and I plus plus, and then we would say C of I dot clear. So basically we are just clearing of the global thing, because it might be a scenario that due to the previous test case, this array has something. Okay. Now we would start building up the graph. So we would start from the very first. So we would start from the second number. Why? Because for root, the parent is -1. So -1 is nothing, but it indicates that root has no parent. So if root has no parent, then there is no point in considering its parent. We would start from the next element. So for int I is equals to 1, I is less than n, and I plus plus. So we would say that if parent I is true, then C of P of I minus 1, because the nodes are given in one index, but we are processing it in 0 index. So we would subtract -1 from everywhere. Dot push back I. Basically, index is already 0 index, so we don't need to do anything else. Then we go down. Then we would initialize whole of the DP array with negative infinity. Negative infinity, the smallest possible value. So for int I is equals to 0, I is less than n, and I plus plus. And then we would say for int j is equals to 0, j is less than 2, and j plus plus. And then for int L is equals to 0, okay, L is less than k, and L plus plus. And then we would simply say that dp of I, j, and L is equals to negative of INF. What is INF? INF is the largest possible value of long, and we are just assigning the negative of it. It's just that we want all the values in the DP array. Suppose we want to take out the maximum value in an array. So if we want to take out the maximum value in an array, we initialize the variable with a very minimum value. It's the same way we are doing it here also. Now we would say answer is also equal to negative INF, because we want the maximum value. Okay. Then we would start the DFS from the root node, that is 0. Okay. Here it is given 1 is the root, but we are making it 0 indexed. Okay. So 0 would now be the root. K's value is already given. Then we have the values of A and B. Both are passed by reference so that we don't make a copy. And then we return the answer of it. Now let us just see. Okay, I made a lot of mistakes. Long, infinite. Okay, this seems like a silly mistake. Yes. Okay. So we have missed some conditions here. Okay. Just let me see to it where we have missed a condition. Mm-hmm. 1 0 0 1 2 3 4 5 1 2 3 4 5 220 long INF int is equals to long answer. Okay, x and k vector int a vector int b, and then we have we are iterating over the neighbors. Okay, first we are iterating for k minus 1, then dp of y of 0 comma I plus 1 is equals to maximum of dp of y0 I plus 1. Fair enough. Then a of I plus dp of x 0 and I. Okay. Then dp of y1 and I plus 1 is equals to dp of y1. This would be the maximum, and then this would be nothing else but by plus dp of x comma 1 comma I. Okay, fair enough. Then we have consideration for int I is equals to 0, I is less than k, and I plus plus dp of y00. Okay, dp of y00, a of y plus dp of x comma 1 comma I. Fair enough. Then dp of y10 is equal to dp of 0 comma by plus dp of x 0 I. Okay. Okay. Seems like this is correct. YKAB. If C is empty, if C is empty, for int I is equals to 0, I is less than 2, I plus plus. For int J is equals to 0 and J plus plus. So we have answer is equals to maximum of answer comma dp of x comma I comma j. Okay. C I dot clear. Fair enough. For int I is equals to 1 pi of I dot pushback I. Okay. This is also correct. I should have initialized L plus 1 dp of I, J and L. Okay. I have not initialized the base condition. dp of 0, comma 0, comma 0 is equals to k of 0. Like if there is only one to consider, we would either consider a. If it is 0, 0 is for a, and dp of 0, comma 1, comma 0 is equals to b of 0. Okay. And we would hit compile and run this time, and this should run. Okay. Okay. Fair enough. Let's see. Thank God. Okay. Fair enough. So now tell me. So upper one is already done. Tell me at this point, what do you don't understand? Tell me. सर मुझे डीपी समझ ही नहीं आता 3D मुझे सर मुझे डीपी ही नहीं समझी कि डीपी 3D क्यों है. DP is 3D. Why? Because see, we index is also important. What index we are considering? Then we also want to know that we are considering which array, array A or array B. Okay. Then we are also concerned how many value of k we have assumed already. Both are already important. Both are a dynamic variable. Both would change. That is why this is not. सर सेकंड फंक्शन में आंसर सेकंड फंक्शन में रिटर्न आंसर गलत कर दिया. No, this is a correct solution. I have just submitted it live. तो सेकंड फंक्शन में रिटर्न आंसर गलत कर दिया. No, we actually this wasn't working because I didn't initialize the base condition. By the way, Aman Jai Singh, are you the same person from Chitkara University? Just confirming. Anyone else who is not able to understand a little bit quick so that I can have my dinner? I would wait for the next 1 minute. Please give me a quick reply. And now the last one. Okay. So tree formation, I need to remove this. Okay. So see the problem for the next 30 seconds and then I would. So just quickly tell me if I'm clear or not. How much time will be required to complete the DSA? It entirely depends on the amount of time and the amount of problems and the quality of problems you are working hard upon. Simple enough. There is no streamlined time that in 1 year or 2 year it would become grandmaster or 6-star or a candidate master. There is nothing like this. Okay, we would be moving forward. So in this problem is a very interesting problem in terms of mine. Okay, so I would stop sharing. I would Mhm. Share this window. Okay. So now see, in this problem, we are given a tree. Okay. We are given a tree. Okay. So we are already given a tree, and then you need to consider that everyone has no edges. Okay. So everyone has no edges, and then you need to start adding edge. So when you add an edge, you would encounter a cost, and the cost is what? If you add an edge between A and B, then the cost of adding an edge in A and B is that after adding the edge, degree of A multiplied by degree of B. This would be the idea. Okay. So now we remove this. Okay. Now we talk about what is known as degree. So there are two terms. First is degree. So degree are the number of nodes, total number of nodes that is emerging or getting into a particular node. And there is also a concept known as in degree, out degree. In degree means that the number of edges that is coming to that node. Out degree means number of edges coming out of the node. And degree is nothing but in degree added with out degree. Okay. This is in degree added to out degree. What is in degree? Number of edges that is coming to that node. Out degree is number of edges coming out from that node. Okay. Emerging out from that node. Okay. So now what you need to do is you need to build up the tree in such a way, you need to start adding the edges in such a way such that the cost, overall cost is minimum. Am I clear with the problem statement? First I would explain you the test case. Mhm. Okay, so see, in this one, this is 1 2 3 4. So 1 is the parent here. Okay, two's parent is 1, three's parent is 2, so 3 would be here, and four's parent is also 2, so 4 would be here. Now we need to start adding the edges. To start adding the edges, what we can do is, one's parent is 1, don't worry, two's parent is 1, so first we would add this. After this, the cost would be 1 has a degree of 1, so 1 multiplied by 2 has a degree of 1, so 1 multiplied by 1 is equals to 1. So up till the cost is 1. Okay, now the next. Okay, let's write the cost of this also. 1 multiplied by 1 plus 1. Okay, so 1 multiplied by 1, 1 multiplied by 1, that is how the finally this is coming. Now we have from 3 to 2. So first we would add this. Okay, now 2 has a degree of 2, so 2. 3 has a degree of 1, so now 2 multiplied by 2, 1 is equals to 2. Okay, now this time we have 4 to 2, so we would just do this. Now after doing this, 2 has a degree of 3 and 4 has a degree of 1, so 3. So 1 plus 2 plus 3 is equals to 6. That is why the output to this is 6. Now let me take the next test case. The indexes are 1, 2, and 3. Okay. So we can say 1 would be here, 2 would be here, and 3 would be here. So 3's parent is 2. So we can say 3's parent is 2. So now we can just add an edge from 1 to 2. Okay. So after adding an edge from 1 to 2, the cost encountered would be 1 into 1. So 1 multiplied by 1. And next we have 3 to 2. So we would add an edge. After this, 2 have an degree of 2, because 2 nodes are emerging, 2, multiplied by the degree of 3. 3 has a degree of 1. So this is just 1 plus 2, that is equal to 3. That is how this answer is coming up. Am I clear with the sample test cases or not? Give me a quick one. I'm clear with the sample test case. Give me a quick one if I'm clear with the sample test cases or not. Mhm. Just let me see. Okay, the number of people are actually very dropped. Okay, number of people are dropped, so there is no point in waiting. Okay, so I would just move forward. Okay, so by seeing this sample test case only, we can see that we can build up the graph. Okay, we can build up the graph in the same way as it is given, and we don't really need to build up the graph. Why? Because whenever we have an edge from A to B, we can say that the number of degrees of A would also increase and the number of degrees of B would also increase, and we can just store the degree at the end. Whatever is coming in the form, we can just multiply it. So like it's just like that, that initially we can do something like this. Okay, let's take the this value. So see, something we can do like this. Okay, so we know that this is 1, this is 2, this is 3, this is 4. Okay, so we know that we have an edge from 2 to 1. 2 to 1. So this is 1, this is 2, this is 3, this is 4. So the number of degree everyone initially is 0. Okay, so now I can say that 2 to 1 there is an edge. That means both would have an increment of degree 2 to 1. Okay, so this would become 1, this would become 1. So now what I can do is I can simply add these two in the answer. Like however the graph is building up, we can add the degree, we can add it to the result. So degree of 1 multiplied by degree of 2. So 1 multiplied by 1, we would get added. Okay. Next is 3 to 2. So 3's degree would also increase, 2's degree would also increase. Okay, now both have increased. So it is 3's degree multiplied by 2's degree. 2 into 1, that is equals to 2 multiplied by 1. Okay, then we have 4 to 2. So 2's degree would also increase, 4th degree would also increase. So now 2's degree is 3 and 4th degree is 1. So now the values would be 1, 2, 3. So 1 plus 2 plus 3. So we can just have an array. Initially all the values would be 0. And then if we observe an edge from A to B, then that means that we would first build up the graph, add the cost to the answer, computed answer, global answer, and then increase the degree of both of them. If we have an edge from A to B, then that means both the degrees would get added up. At the end, we would just have it. How many users are there? Video is lagging. Is it for everyone? So just tell me. Let me check the internet connectivity. It's good. Let me see the upload speed also. This is also good. Okay. Can't really help then. My internet is good from my side. Might be an issue with the servers of this. Okay. So yes, what I was talking about. A window, and then we have. Mhm, mhm. Sir, it is fine. Okay. Thank you so much. Okay. So now we directly move to the implementation. To be honest, this is an easy problem. The intuition is a bit hard, but due to weak sample test case, if we just build out the sample test case, then this problem is easy. That is why you should always have a pen and paper with yourself. Okay. So what we can do is we can have a vector int degree of size n. Initially, the degree is 0. Now we would have the long sum is equals to 0 because we need to return the value in long. Okay. Then we come at this point and then we start from index I is equals to 1. Okay. Because 1 parent is -1. It does not denote any edge. So we would start from the next node. Okay. So I is less than n and I plus plus. From here we have the edges. So now we would say degree of I, we would add plus plus to it. Okay. And degree of parent I -1, because we are making it 0 indexed. Okay. That would also get added because we have an edge from that index to parent. So both would get added. Both index we have added. Now we would add that values to the sum. So basically this value, I'm not writing it because I want to show you how we are computing the value. This value multiplied by this value. Okay. At the end, we would just return the sum. Compile and run. The solution given in the editorial is a bit confusing, but this is more intuitive, to be honest. Just do as we are getting. Just do it as we are getting, and at the end, print the result. Solved. Tell me the line number at which you are not able to understand. Tell me a little bit quickly because I need to take my dinner. And this problem seems to be an easy one. Quickly tell me the point at which you are not able to understand. Tell me the line number, and then I would quickly. So getting an AC over the second problem in a live contest was a commendable thing from my side. Okay, like I think that I have improved over myself. Yes, this is a kind of easy problem if you are able to get the intuition. Like what is the question, how to solve it, then this intuition is very easy. Anyone else who is not able to understand, give me a quick reply. Okay, so I would wait for the next 30 seconds. Sir, how are you with same energy from the morning till night? Basically, to be honest, sometimes I don't have energy. Okay, sometimes I don't have energy. Sometimes I don't feel like smiling. Okay, because I like from the morning I wake up at 6, then till 12 also I do streams and all. Okay, in the morning also I have batches and all. Zad knows because Zad is in my CP batch. Okay, so it's just that you need to work hard a little bit. Basically, this energy is a kind of like positivity that brings. So I need to have that positivity, even though I don't feel like. From where we can get resource of system design in C++ language. Uh, 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 do it from the system design. Like just I can't say the name because this is a public platform and I'm from Geeks for Geeks. Just search system design, and the only person you would be getting is one person only. I would just give you a hint also. He is having his own startup. Currently, he is running his own startup. Okay. Anything else you want to ask? So, to the last point. Okay. So I tried every possible way to explain you the solution and tried to make it as intuitive as possible. So if this contributed in your learning curve, or you are able to now, suppose you understood the solution, kindly comment on the video your feedback, because I just want to see for how many people I am clicking and for how many people I'm not able to click. Then I would change my teaching methodology. Okay, that's it for today. Just give back to the community so that should remain free. This post contest analysis, this contest, both should remain free. So just support it and give back to the community. Thank you, everyone.